Hey guys, in this tutorial we're going to take a look at how to create this sort of back plate or panel. I sort of imagined it as something that you could attach to your back, I don't know, for whatever reason, piece of armory or something, I don't know, but here's just a quick render I did of it before. This shows what it looks like on the bottom. It's cool, this is what we're going to be making. Let's jump into a new document. So I'm going to start with a series of graph mappers. So I'm going to set this to Bezier. I'm going to set another one to sine, and I also need a range component, which I'm going to plug into each of these, and I'm going to increase the slider to 64, which is going to be my number of steps, and I'm going to multiply this result. So I'm going to multiply this coming out of here, oops, with two sliders. Two sliders, you ask? Yes, that's because we're going to be creating, if I just flick, let me see, if I just flick back to my render, we need one slider to control this inner edge and one to control this outer edge, because you can see it's not as simple as just a translation. It also, it's sort of the movement is a bit more exaggerated in this outer one. You can see it doesn't stretch quite as far. Alright, cool. So before I make a copy of this slider, I'm going to set this to a maximum value of 100, and then I'll make a copy of it and plug it in. And then we're going to throw down a construct point, and this is going to be my y value. So I'll just move this over, and I'll move these over as well, and straighten them up. And we're going to put down another multiplication, and I'm going to multiply these two results here. And then I need another multiplication. Instead of doing that, I'll just make a copy of these. And okay, actually I realized I forgot to graph this input, because we want each of these to be manipulating this data list separately, so we need to put them each on their own separate list. So my first one and my second one is a bit longer, and then we'll I'll plug this into our x value, and I also need to graph these here and pull these out. Cool, so for this first one I sort of want maybe 1 1/4 sine waves. Well, I say sine wave, but technically this is a negative cosine wave. And then this one, we sort of want a nice trough just off center. Something kind of like that. And the other thing we need to do is we need to throw in an addition here, because I do want these to be in different positions. So let me just quickly move these around just so it's a bit nicer to look at. Plug those in. Oh, let me don't forget to hold shift when you're plugging multiple items in. And this is my new x value. Alright, there we go. So it looks like I could probably exaggerate this inner one a tiny bit more. Oh, that's the outer one. Do the inner one as well. And now let me just tidy this up. So I sort of want this over here, and I'll have 3 sets of these sliders all lined up. So these two are my multiplication. Let me just align those. Alright, cool. And now I need one more graph mapper for my z value. So let me just make a copy of this and this. Oops. Grab those, and I'll plug this in here. and this is going to be my Z value. And so for this one, we sort of want the opposite. We want a peak slightly off center, and we want it to be a bit sharper. And we want the outside one to be lower. So something like that looks good to me. So now I'm going to interpolate these curves. Alright, now I can preview all of this off because we've got our two curves, and I can loft them together. And we're not noticing result at the moment because they're both on separate lists, which doesn't help us until we flatten. And there we go. So now what I'm going to do is I'm going to mesh this surface. And I'm going to plug in two sliders. I'll give them a maximum value of maybe 30. One for my U and one for my V divisions. Let me turn these off. And so I think my U divisions, yes, so they're along the width of my panel. And then this one controls the divisions along the length of the panel. And so what I do want to do at this point is I want to deconstruct this mesh such that I could extract this middle edge loop. And so the way I'm going to do that is with a mesh explode. And then I'm going to use a partition list. Pardon me. And now we need to use either one of these sliders for the size of our partitions. I'm going to guess and say that my V value is the correct partition to use, and we'll just test that now with a list item. So what this will probably give me is a row of 5 faces. Yes, exactly as I would have expected. And so this isn't quite what we want yet, but this is giving us the correct result. It is giving us a line of faces. You might be wondering, oh, wouldn't it just work easier if you plugged 5 in? Well, if I do, it is going to select every 5th face, every 18th face in the wrong direction. So not quite as helpful to me. Although, I mean, it is a cool, you could imagine this could be quite a cool sort of nifty little animation if I would just plug this slider in here. You know, that's, I mean, you could do something with that just with this sort of irregular picking method. Alright, but anyway, back to what we were doing. We plug 18 in, and that gives us a row of faces. All we need to do is flip the matrix. And then when we pick a list item, it's going to take that whole row of faces. Now, okay, we could do it like this at this point, but what I do want to do is create my mirrored piece of geometry. So I'm going to mirror this through the XY plane. Oh, sorry, what's that? Through the YZ plane. And you can see they're quite far apart at the moment. So maybe I will bring in these addition values so that we do have something which looks a bit better. Yep, I think that's about right for me for the moment. And so, yes, so we've mirrored this other piece of geometry, and what we need is to merge these two data items together. So we're going to merge mesh 1 and mesh 2, and I don't need D3, so I can get rid of that. And then I'll plug this into my mesh explode, and you'll notice our flip matrix immediately breaks. And that's because we now have a 3-dimensional data structure. Wee-hee. So now I'm going to throw down my path mapper. I'm going to simplify this input just in case we've got an extra layer of data that's not doing anything, and I'm going to create null mapping. So now I'm going to grab out my param viewer as well, and we'll see what we've got. So at this point, okay, so this, when we picked a list item from here, it was taking just a row of 5 items. So what we need is we need to bring this row, these 18, this index of 18 into our path indices. And so the way we do that is we bring our I for our index number in, and then over here we remove the hierarchy for B and replace it with I, so that these and these are swapped. You don't need to put B over here, but you can if you want. I leave it out just because it's more efficient, you know, by that extra 5 seconds. And so now we've got our row of faces for each part of the mesh. Now what I will also do at this stage is we could use a slider to control which edge loops we're pulling in. But what I would prefer to do is create an expression. And so this expression is going to be the 4 of x over 2 plus y. And so when we plug x into here, this is always going to give us the middlemost item. And then I'm just going to plug this slider in here. So you can see as soon as I plug this in, it's going to give me my middle item. If I were to bump this up to 29, you can see it's still giving me that middle one. Of course, we don't want it up to 29. 5 is good for what we want. And this, I'm going to give it a range from negative to positive. So if I want, I could shift this one way or the other, just as you want an extra layer of control. Alright, so now we've got this row of faces. I also need to create a cull index so that I can pull out those other items that I do not want at the moment, but I do still want for later. Alright, so this I can just leave alone. And what I'm going to do is I'm going to use a cull. Well, I'll show you the cull pattern first. I need to flatten that. Oh no, not flatten. I need to shift my paths because we still have a two-dimensional data structure. So I'll shift those, and this is going to allow me to pick out particular faces. So now I'm going to grab panel, and I'm going to say true, false, and use multi-line data, and that is my input. Cool, so you'll see what we're getting is every other face, except it is giving me this end face as well, which I do not like. So what I'm going to do is I'm just going to change this V count to be odd numbers. So that way we're always going to have that bit of padding, except it is giving me now the exact opposite of what I want. So at this point what I'm going to do, instead of using a cull pattern, is I'm going to use a dispatch. So what the dispatch does is it basically the same thing as the cull pattern, but it puts your true items into your A list and your false items into your B list, which is quite helpful because we're going to use both of these, if not now, at least further down the track. So now I'm just going to test which one is which. I'm probably going to want my B items. Yes, so you can see we've got that layer of padding on either edge, and I can just preview these off. So now I'm going to deconstruct this, these meshes, and in fact actually what I will do is I'm going to use a component, it's called bang or explode tree, and what it does is it puts the tree branch onto its own separate list. So we have tree branch 0 and tree branch 1. I'm going to deconstruct those separately, and you'll see why in a sec. And that's because I'm going to use a by arc. And so I need to pull out vertices for my, these ones are my start vertices, and these ones are my end vertices. And we need a tangent vector at the start and a tangent vector at the end, which is our normal in each of these cases. And it looks like we have, should we say, well, our faces are facing the wrong way. So when I have this left over here, I should just be able to flip my surface direction. Oh, no, actually, no. What I will need to do is mesh flip. This mesh flip component is it is from the Uto plugin, which I have talked about before. This is the easiest fix. If you do not have access to the Uto plugins, they're also called MeshEdit. I'll put a link in the description. The other way you could fix this is just by using a negative value on this normal. And there we go. So that's two ways you can fix it. I'll keep the mesh flip for later. Alright, so now we've got this by arc, and I'm just going to preview this data off. Okay, so now what we want to do is we want to explode these by arcs. And what we're going to do is we are going to, let's see, so what we're going to do is we're going to basically turn, each of these exploded by arcs will give us 3 points, the start, the middle, and the end. So what we need to do is we need to flip this around so that what we're going to get, instead of 3 points for one arc, we want 4 points from each of the arcs for each of these locations. So let me just simplify this to get rid of any padded zeros, and it looks like we need to swap our branch B with our index I. So we'll grab our path mapper, and we're going to create null mapping, and we'll bring in my I, and we'll flip this around. So AI. And now we should have lists of 4 items each. So using this, we can create polylines. Alright, very good. And so at the moment we are getting, okay, they're not closed properly, and that's a very simple fix. We just invert this boolean over here. And what I'm also going to want to do is I want to be able to scale each of these individual rectangles. Well, rectangles, parallelograms, 4-sided shapes. And the way I'm going to do that is I am going to use an average component, and this average component is going to give me the center of each of these polygons. That's the word I was looking for. And we're also going to need to, okay, I'm going to want to scale only the center one, because the end one already fits perfectly into the hole that it needs to. So what I do need to do is I need to shift these paths for starters, so that we'll have 3 items per list. Same thing over here, 3 items per list, and we're going to use a scale. So my polylines are the geometry I'm scaling them about their center points, and I just need to figure out how to keep these end ones fixed. Luckily, that's pretty simple. I'm going to create 3 parameters for scaling. Actually, I'm only going to create 2 because the first and last one are going to be the same, and I'm going to merge them together. So the first one's constant, second one is a variable, and the third one is constant as well. And so I'll plug this into my factor, and you can now see that if I turn this off and I select my scale, we have a full-sized rectangle at each end and a scaled one in the middle, which we can scale independently. And so now I'm just going to loft through all 3 of these. Alright, so there we go. That's all working pretty well. I can preview all of this off again. Now what we need to do is we need to use our mesh surface component again, and we won't be able to use it straight off the bat because these are all B-reps. So we're going to use our Deconstruct B-rep component, plug it in, and now we can mesh surface. And I need to plug in 2 sliders, one for my U and one for my V. I'm going to set this to, let's see, go to maximum of 10, although 10 might be a bit overkill. And we'll plug in our U and V. So I think my V is going to be my sort of width divisions, and my U, yes, my U divisions are along the length. So I'll turn these off, and there we go. We're almost there. Now what I need to do is I need to join all these meshes up. So I'm going to use a Weaverbird join, and now I need to find the rest of the meshes from before. So what I am going to do is I'm going to put a little mesh component over here, and I'm going to take my merge, and I'm also going, actually no, that's not the one I want. I want my cull index, and I also need the other item from my dispatch. And so let me just preview this off now. And so now what I need to do is I need to add these into my Weaverbird join, and then I preview those off. I'll flatten this, and we're just going to use a weld vertices component to test whether or not our meshes have joined correctly, whether we're getting any sort of normal issues. And I do have a feeling that we're going to have some normal issues on this face here just by looking at it. It does look slightly darker than this one over here. So when we bake this out, yes, we can see that there are normal issues. And if you're not familiar with normals, basically each mesh face has a direction perpendicular to that face. And so if all the normals align, what you should get is this sort of attempt to blend across faces very smoothly, or such that we can't actually see that there is such a sharp difference between these two faces. But if the normals mismatch, we get a very horrible blending situation where then one set of normals is facing outwards, one set of normals is facing inwards, and so the way it deals with that is by having this incredibly harsh line from white to black. Alright, so we know we need to fix that. And so the way we do that is we need to be able to isolate this first mesh. So we do have it over here, but that is without the data removed that we wanted to remove. So what I am going to do is, let's see, I'm going to start by simplifying this here, and let me just bring this mesh component a bit closer for now. Okay, so what we will need to do is we will need to, okay, if I grab my param viewer really quickly and just inspect what's coming out of here, we can see that we do still have in our hierarchy our first mesh given by path index 0 and our second mesh given by path index 1. So that's super useful. We should also have that for the dispatch. Yes. And so what I can do is I can just shift the paths coming out of here, and I'll disconnect this here and then plug this in. And so now we should have just two lists coming in here. We don't need to do it because this one was already matched up fine. And so now we just need to use our bang component again, / explode tree, and we just need to mesh flip the correct face, which is this one here. And so then we can just create another mesh node, plug these in, and let me just replace that. Turn these off, and then when we weld our vertices, there we go. We should have proper smoothing across the mesh. Alright, so then the next thing we need to do is we need to smooth these out. So I'm going to use the Weaverbird catmull-clark subdivision. I don't know if I've actually talked about the catmull-clark subdivision properly before, so I might as well do that now. The catmull-clark subdivision is a really great subdivision method because no matter what kind of geometry you plug into it, you're always going to get quads out of it. And the reason for that is because basically it looks at each mesh face and it wants to subdivide it. And subdivision method is basically it draws a line from every edge to the center, from this edge to the center, from this edge to the center, and from this edge to the center. And by doing that, it's always going to result in a completely quadrangular mesh. And so every time you increase the level of subdivision, it divides each of these faces into 4 more faces. And then if you were to do it one more time, it would divide each of those faces into 4 more faces. So basically, the amount of faces you're going to end up with based on your initial mesh is whatever this is. So this is 532 times 4 to the power of the level. So 532 times 4 to the 1 is 2128. 532 times 4 to the 2 is 8512, and if we were to do 3 subdivisions, we're doing 4 times 4 times 4 times as many faces, which is 64 times as many faces. And so you might be tempted to push beyond this. And so if you were to try and, I'm just going to put this up to 5, if I were to plug this in, thinking I'll get a really smooth mesh, that's not going to happen. What Weaverbird sort of has this safeguard so that you don't push beyond 3 levels of subdivision, because there's a sort of idea that you should be able to smooth out any object within 3 levels of subdivision. If you can't do it within 3, okay, occasionally you might need to do it with 4. I've only ever had to do that once just because I wanted to get it that little bit smoother, but 3 subdivisions should be enough. So Weaverbird is not by default going to let you do more than 3, because then you're doing, what's 4 times 64? That's 240, 256 times the initial number of faces, and that's quite a lot more. That can really jump up your face count and potentially crash Grasshopper. So Weaverbird by default disables that unless you turn on dynamic preview. And so you'll hit, we have to hit no here, and now we're going to get a super fine mesh. And so we could even punch this up to 5 if we wanted, but you can now see it's becoming very unresponsive. You can also see that if we were to bake out this mesh with 5 levels of subdivision, and we would also bake out this one with 3 levels of subdivision, you know, I'll be honest, there's not a whole heck of a lot of difference between them. In fact, I'd imagine you'd be pretty hard pressed to notice anything straight off the bat. So if you're rendering or 3D printing or anything, 3 levels of subdivision is perfectly well and good for those purposes. Yeah, so that's the catmull-clark subdivision method. Now what what I can also do is I can set these I do have some options with my catmull-clark, and that's to do with how it deals with the naked edges. So you can see at the moment it's really smoothing out all around there, and that's, that might be all well and good for what you want, but maybe I want all the naked edges to be fixed. I want those nice hard edges, but okay, maybe I don't like that because that's also giving me these hard sort of edges along here as well. I want these to be smooth. I only want the corners to be fixed, and what do you know? There's a method for that too. We can just set our our naked edge method to corner fixed, and then everything else follows what's called a sort of I believe the catmull-clark subdivision method is said to tend towards a B-spline, so that's how it gets the sort of smoothing across the mesh by trying to tend to this quadratic shape. Alright, so that's probably enough theory on the catmull-clark subdivision for the moment. What I'm going to do is I'm going to put in a Weaverbird thicken so that I can plug this in. Actually, no, there is one more crucial thing that I should say about the catmull-clark subdivision method, and that is if you are moving your geometry across different platforms, say you wanted to render this mesh in 3ds Max, that's something I do a lot. What I would highly recommend is you bake out this lower resolution version and then you export that, because this catmull-clark subdivision method is a standard across every single 3D platform basically that works with meshes. It is exactly the same in any program. It will always produce the same mesh result in terms of how it smooths it and how it looks. But if you are baking out this lower preview, then you are going to get a much... You're really saving on file size, and I can't really emphasize how useful that is. I mean, if I were to export this file out as an OBJ now, it might only be 60 kilobytes or so, but if I did a couple of subdivisions, that could easily reach a few megabytes. And so it's really just quite an efficient way to work if you're working with your low resolution geometry across multiple platforms. It's sort of under this umbrella term called subdivision modeling. Alright, cool. That's probably enough on that now, I'm pretty sure. Alright, cool. So now I can plug my Weaverbird thicken into my catmull-clark, and I'm going to take down my distance offset because that's just way too much at the moment. By default, Weaverbird thicken is set to 5, but I would be quite happy with what's that? 1.151. Let's just bake it out and have a look. Alright, so there we go. That's basically the result we're after. I think that looks pretty good. One other sort of level of control that I could show you how to build into this is something to do with our bi arc. So what I could do is I could average these verts from here and here. Actually, wait, I want to average them together, but that's not going to work straight off the bat because their data structures don't match exactly. So what I want is a path mapper for starters, and I'm going to plug this in, create null mapping, and for once I'm going to take down my A path. I'm going to do this for both sets of vertices. And so while here we had however many lists of 4 items, what we're now going to get is half the amount of lists with 8 items. So this is going to give us a curve right down the middle. And so now I'm just going to take all of this, oops, I'm going to take all of this and move it along a little bit. Actually, probably a little bit more. And I'm going to throw a curve in the middle here. Alright, so now I'm going to reference this curve in. Set one curve, and I'm going to do a curve closest point. So my points come from this average, and my curve is here. And so now what I can do is I can use this to define my ratio of my bi arc. So I'm going to use a remap numbers component. And so the ratio is a value from 0 to 1. And so I need to change my distance values from 0 to 1. So the way we do that is with a bounds component. Plug my distance in and flatten it. And that's my source domain. This is my list of values. And my target domain is going to be another domain on this side. So I'm just going to plug in 2 sliders here. Whoops. And move those over. And then this goes into my result. And so immediately it skews to the left just because both our domains start and end at the same value. And as we move this over, we can see we're getting a bit of influence from our curve over here. And so now we could turn the points on for this curve, and we could start to mess around with it a bit. I mean, you don't need to do this. This is just me showing you another way that you can throw some control into here, and you can use this to sort of modify the bi arc ratio and shift these either which way. Cool. So that's the basics of this definition. Let's look at what we can tweak. We can tweak our offset distance. We can tweak our sort of the shift to the left or right. We can change which of these, should we say, which of these row of faces is our information coming from, is the link between these two panels. We could go back and modify these graphs. We can do whatever we want with it. And we could also go and control any of these values for how high these are, how wide they are, how far apart they are, anything. Cool. hope you enjoyed this tutorial.